At 11:47 p.m. on November 15, 2025, Universal Time, the universe stopped being a quiet backdrop and became something else entirely. For decades, we've pointed telescopes at the sky, convinced that if anything truly extraordinary ever happened, it would be far away. A dying star in some remote galaxy, a faint radio whisper that could always be explained away as a glitch. But what unfolded on that night didn't come from a distant corner of the cosmos. It happened here, inside our own solar system, and it has forced the entire scientific community to admit a possibility most of them were never truly prepared to face. The object at the center of all this is one you already know by name, 3I ATLS. For weeks, it was treated as just another strange visitor from interstellar space, a curiosity, a fascinating anomaly to be studied, debated, and turned into plots for sci-fi movies and late-night podcasts. Astronomers tracked its path, measured its brightness, ran orbital simulations, and told themselves that, mysterious as it seemed, it still belonged to the familiar world of gravity, ice, rock, and dust. It was weird, yes, but it was still natural until it wasn't. Because at 11:47 p.m., something happened that no model, no textbook, no neat little equation could explain away. 3I Atlas didn't just drift. It didn't just vent a little gas and wobble on its path like a normal comet. It executed a move, a controlled, unmistakable, brutally obvious maneuver that every observatory on Earth saw at nearly the same time. The infrared signatures spiked, the trajectory shifted. The numbers coming in from observatories on 5 continents told a single, terrifyingly simple story. This object had just used propulsion. That's the moment when the tone of every conversation about 3I Atlas changed. The jokes stopped. The speculative headlines suddenly felt too small. In control rooms from Pasadena to Tokyo, tired scientists blinked at their monitors, ran their diagnostics again, and realized the problem wasn't their instruments. The problem was reality itself. What they were seeing should not be possible with any known natural process. It didn't match comets. It didn't match asteroids. It didn't match anything we have ever launched into space. It was as if the universe had quietly decided to demonstrate an engineering trick centuries ahead of our own and chosen to do it right above our heads. Let that sink in for a moment. Because everything else that follows, every number, every signal, every desperate meeting behind closed doors rests on one simple, unavoidable conclusion. 3I Atlas is not behaving like an object. It is behaving like a machine. Tonight, we're going to walk step by step through what actually happened. We'll look at how a body with the mass of a small mountain managed to change its speed in minutes, why that maneuver has put it on a disturbingly precise path toward the inner solar system, and what kind of power source you would need to pull off a stunt like that. We'll talk about the strange radio patterns, the laser-like flashes, and the X-ray bursts that appeared in the exact same window of time. And we'll ask the question no one wanted to ask out loud until now: if this is technology, whose technology is it? Because once you see the numbers, once you understand the scale of the energy involved, one thing becomes impossible to ignore. This isn't a glitch. This isn't a coincidence. This is an announcement. And the most unsettling part is not that 3I Atlas moved. It's how it moved, and where it's heading now. What happened in the minutes after that sudden spike in infrared emissions is now considered one of the most astonishing mechanical feats ever recorded in space. To understand the scale of it, you first need to understand the sheer mass of 3I ATLS. This object isn't a drifting ice ball or a dusty fragment from some forgotten system. Based on combined radar, spectral, and photometric data, its estimated mass is roughly 33 billion tons. That's not poetic exaggeration. That's the mass of a small mountain accelerating through space at tens of thousands of kilometers per hour. And yet, in a span of just 14 minutes, that mountain changed its velocity by 4.3 kilometers per second. Numbers like that don't just break our models, they obliterate them. A natural object of that size cannot simply decide to accelerate. There is no known cometary outgassing powerful enough to generate that kind of thrust, no internal pressure buildup capable of pushing something that heavy with such precision, and no gravitational interaction in the vicinity strong enough to account for the change. Scientists ran the simulations repeatedly, trying to force the data to fit some natural explanation, but nothing even approached the observed result. The energy required for that maneuver is so large that the human mind has difficulty imagining it. To put it into perspective, achieving a 4.3 kilometers per second velocity change for an object of that mass would require an energy burst equivalent to 70,000 nuclear warheads detonating at once. Another way to view it, you would need the total amount of solar energy that hits Earth's entire surface over the course of a full day compressed into minutes and focused into a single directional impulse. Humanity has never built anything capable of pushing even a fraction of that mass with even a fraction of that speed. Even our most powerful rockets, Saturn V, Starship, SLS, would be like matchsticks glued to a skyscraper by comparison. Experts immediately turned to theoretical propulsion concepts to see if anything on our drawing boards could match the numbers. Chemical rockets? Impossible. Nuclear thermal propulsion? Still off by magnitudes. Advanced ion drives? They provide steady acceleration over months or years, not minutes. Even theoretical fusion engines or antimatter propulsion technologies that exist purely as mathematical exercises would struggle to replicate the observed performance. In fact, early calculations suggest that even a perfectly efficient fusion drive would require fuel masses larger than the object itself. That means whatever pushed 3I, Atlas, isn't just beyond our engineering. It's operating on principles that sit far outside the limits of our known physics. But power isn't the only shocking element, it's the precision. If this were some chaotic burst of internal energy, the object would have begun tumbling or shedding material. Instead, the change in velocity was clean, stable, and directional like a long, controlled engine burn. The telemetry doesn't lie. 3I Atlas didn't erupt, it maneuvered. And when an object this massive performs a controlled maneuver of this magnitude, it forces a question that scientists rarely speak aloud. What kind of intelligence builds something that can move like this? But even that question falls short, because the most unsettling revelation came next, not from how 3I Atlas moved, but from where that maneuver sent it. When the shock of the maneuver itself finally settled, astronomers around the world turned their attention to what mattered most, the new path. If this had been a random outburst, some internal pressure release, a structural fracture, or volatile jets firing in unpredictable directions, the object's trajectory would have shifted chaotically. It would have tumbled, drifted, or veered into an orbit that made little geometric sense. But that's not what happened. What happened was something far more calculated. Within hours of the thermal spike and velocity shift, tracking centers from Hawaii to Chile began updating their orbital solutions. The numbers weren't just changing, they were converging. Every independent model pointed to the same conclusion. 3I Atlas had altered its course with astonishing precision, tightening its path into a clean, deliberate arc aimed deeper into the inner solar system. Before the maneuver, the object was expected to pass Earth at a relatively safe distance, close enough to be interesting, far enough to be harmless. After the maneuver, everything changed. The closest approach date moved from early January to December 28, 2025, 6 days earlier than predicted. And the distance? It shrank dramatically. Instead of a comfortable glancing pass at roughly 0.08 AU, the new trajectory brought it into about 0.04 AU. That may sound abstract, but in practical terms, it's roughly 15 times the distance between Earth and the Moon. In cosmic terms, it's a razor-thin margin, shockingly close for a visitor from interstellar space. Objects from beyond our solar system rarely come anywhere near our orbital neighborhood. They behave like cosmic drifters, skimming past on wide, gravitationally neutral paths. They don't adjust their course, they don't correct their timing, they don't aim. So why did this one do exactly that? Astrophysicists couldn't ignore the alignment. The new vector wasn't coincidental, it was intentional. A change of this magnitude wasn't some random twitch in the darkness. It was a maneuver designed to bring 3I Atlas closer, faster, and on a path that intersects Earth's orbital region with unsettling accuracy. That realization sent ripples through every major space agency on the planet. because an object that can correct its trajectory with this level of control is not behaving like a comet or even like debris. It's acting like a vessel. Even more unnerving was the stability of the new trajectory. If the velocity change had come from an explosive or uncontrolled event, the orbital model would show wobble, drift, or chaotic perturbations. Instead, it locked into place as if guided by a navigation system, one capable of reading gravitational fields, plotting solutions in real time, and executing corrections with mathematical elegance. This is where the conversations behind closed doors stopped being hypothetical. When scientists at NASA, ESA, and JAXA compared the new flight path, their private memos contained phrases that had never appeared in any professional astronomical report. Non-random impulse event, intentional vectoring, controlled intercept trajectory. In simpler terms, it aimed. Yet one question rose above all the others. Aimed at what? Not all experts agree that Earth itself is the target. Some argue the object might be navigating toward the Sun, or perhaps another gravitational reference point. But the timing, the distance, and the precision all point toward a narrow corridor of space through which our planet will pass. It may not be targeting Earth directly, but the overlap is too exact to ignore. And as unsettling as that is, this wasn't the only anomaly detected during the maneuver. Because while 3I Atlas was adjusting its path, the sky wasn't silent. It was emitting signals, radio, optical, and even X-ray bursts like a machine announcing its next move. And that leads us to the next question, one far stranger than changes in orbit. What exactly was 3I Atlas trying to say? If the maneuver was the moment scientists realized something was wrong, the signals were the moment they realized something was impossible. Because during the exact same 14-minute window in which 3I Atlas changed its velocity, the entire electromagnetic spectrum lit up with activity coordinated, structured, and unmistakably artificial. It began with the radio telescopes. Facilities from the Atacama Desert to the Australian outback reported a sudden burst of emissions spanning from 400 megahertz to nearly 40 gigahertz. That range alone is bizarre. Natural radio sources, pulsars, quasars, gas clouds tend to produce either narrow, predictable emissions or chaotic noise. What they don't produce is a layered, multi-band transmission with mathematical consistency. Yet, that is exactly what appeared on astronomers' screens. Not a hiss, not static, but patterns. Patterns that repeated, modulated, and seemed to carry encoded information. Scientists scrambled to explain it away. Plasma interactions? No. Dust impacts? No. Some bizarre thermal resonance? No. Every hypothesis collapsed as the data came in. Because the signal wasn't just structured, it was deliberate. But the radio bursts were only the beginning. At optical wavelengths, telescopes equipped with high-speed photometers captured something even stranger. Laser-like flashes of blue and green light, each burst separated by microsecond-level timing. Natural processes don't behave like that. Random events don't repeat with the accuracy of a metronome. And certainly nothing in nature emits perfectly coherent, monochromatic light in pulses that could be mistaken for communication signals. Yet here it was, flashes so bright they were detected from over 150 million kilometers away. At the same time, orbiting observatories picked up X-ray bursts with spectral lines that didn't match thermal emissions. These weren't the signatures of hot gas or explosive heating. They were the kind of emissions you'd expect from particle beams, from charged particles being accelerated to near-light speed and slammed into matter, something you'd see in a particle collider, not in a drifting object beyond Mars. One astrophysicist described it bluntly. It's as if 3 different machines all turned on at once. But perhaps the most chilling detail wasn't the power or the variety of the emissions, it was the coordination. The radio patterns, optical flashes, and X-ray bursts weren't happening randomly. They were linked. A radio modulation would spike, followed precisely by a flash of light, then an X-ray pulse, a sequence, a rhythm, a syntax. This is the moment when the language of science shifted from cautious terms like anomalous event to phrases rarely used outside science fiction. Multi-channel communication systems, synchronized emission architecture, intentional data signaling. In other words, whatever 3I Atlas is, It isn't just moving, it's talking. Researchers at SETI were among the first to publicly acknowledge what the signals looked like. After running them through filters designed to isolate artificially generated transmissions, they confirmed what many already suspected. The patterns showed evidence of information encoding, including error correction traits found in human communication protocols. Think about that. Not only is the object emitting signals, it is doing so in a way that protects the integrity of its message over vast distances, just like any advanced digital communication system would. And if that wasn't enough, the optical pulses and X-ray bursts suggested systems capable of generating and directing enormous amounts of energy with microsecond accuracy. This isn't a rock. This isn't debris. This is a machine one, broadcasting signals across multiple wavelengths, each reinforcing the other, each pointing to a level of engineering far beyond our own. But what was the message? That answer came a few hours later, when SETI researchers isolated a repeating pattern that would change everything. Because buried inside those signals was something no natural object would ever produce, a mathematical introduction, a universal handshake. A message that said, simply, "We know the language of the universe, do you?" And that was only the beginning of the decoding. Hours after the initial signal burst, when the world was still reeling from the maneuver itself, researchers at the SETI Institute uncovered the detail that shifted the entire event from anomaly to message. Hidden beneath the broadband radioactivity was a repeating structure, a clean, deliberate loop cycling every 427 seconds. At first glance, it looked like nothing more than a carrier wave, but its frequency was a revelation, 1.42 gigahertzes. That number is iconic in astronomy. It's the hydrogen line, the single most universal frequency in the cosmos, tied to the most abundant element in existence. Any civilization capable of building a starship would recognize its importance. Using that frequency isn't random, it's intentional. It's the interstellar equivalent of tapping someone on the shoulder and saying, "Let's start somewhere we both understand." But what followed that carrier wave left scientists speechless. Instead of noise, instead of static, the signal unfolded with the kind of elegance you'd expect from a carefully planned lesson. It began with the simplest of all mathematical concepts, prime numbers. Not spoken, not encoded in words, but displayed as pulses 2, 3, 5, 7, 11, 13. Then the sequence reset, not a glitch, but a confirmation, a declaration. This is not nature, this is intelligence. After the primes came something even more recognizable, the Fibonacci sequence. Then ratios. Then patterns corresponding to pi, the golden ratio, and even the fine structure constant, a number so foundational to physics that many scientists joke it feels designed into the universe itself. Each segment was clear, crisp, and structured, building from simple concepts to more complex relationships. This wasn't just communication, it was instruction. According to Dr. Sarah Chen, the lead analyst at Berkeley's Signal Processing Lab, what 3I Atlas sent us was nothing less than a mathematical primer, a universal foundation, a way of saying, here is the key. Learn it, and the rest of the message will reveal itself. It's the same logic humans used when we crafted the Arecibo message and the Voyager Golden Record. You don't start with language, you start with shared reality, numbers, ratios, constants. You start with the architecture of the universe. But here's where things get even more staggering. Beneath the primer lies a second layer, a denser, far more complex data stream that we still can't decode. SETI researchers describe it as something analogous to a compressed holographic file, the kind of high-density encoding you'd use if you were trying to send an enormous amount of information across astronomical distances without wasting bandwidth. To put it bluntly, if the primer is the alphabet, the second layer is the encyclopedia. Now consider what that implies. The object isn't just signaling, it's teaching. It's preparing the recipient to understand a larger message, but decoding that deeper layer isn't just a technical problem, it's a philosophical one. Because it suggests intention, patience, and perhaps most unsettling of all, expectation. Whoever engineered this system assumed the reader would be capable of mathematics, logic, physics. They assumed the decoder would be intelligent, technological, and curious. They assumed someone like us. For the first time in history, humanity wasn't looking at raw data from the cosmos. We were looking at something built by a mind. And as breathtaking as that realization was, the universe wasn't finished surprising us. Because while scientists were decoding the primer, telescopes around the world were detecting something else moving with 3i Atlas in the darkness, something that made the mystery exponentially deeper. Hours after the initial signal burst, when the world was still reeling from the maneuver itself, researchers at the SETI Institute uncovered the detail that shifted the entire event from anomaly to message. Hidden beneath the broadband radioactivity was a repeating structure, a clean, deliberate loop cycling every 427 seconds. At first glance, it looked like nothing more than a carrier wave, but its frequency was a revelation, 1.42 gigahertzes. That number is iconic in astronomy. It's the hydrogen line, the single most universal frequency in the cosmos, tied to the most abundant element in existence. Any civilization capable of building a starship would recognize its importance. Using that frequency isn't random, it's intentional. It's the interstellar equivalent of tapping someone on the shoulder and saying, "Let's start somewhere we both understand." But what followed that carrier wave left scientists speechless. Instead of noise, instead of static, the signal unfolded with the kind of elegance you'd expect from a carefully planned lesson. It began with the simplest of all mathematical concepts, prime numbers. Not spoken, not encoded in words, but displayed as pulses 2, 3, 5, 7, 11, 13. Then the sequence reset. Not a glitch, but a confirmation, a declaration. This is not nature, this is intelligence. After the primes came something even more recognizable, the Fibonacci sequence, then ratios, then patterns corresponding to pi, the golden ratio, and even the fine structure constant, a number so foundational to physics that many scientists joke it feels designed into the universe itself. Each segment was clear, crisp, and structured, building from simple concepts to more complex relationships. This wasn't just communication, it was instruction. According to Dr. Sarah Chen, the lead analyst at Berkeley's Signal Processing Lab, what 3i Atlas sent us was nothing less than a mathematical primer, a universal foundation, a way of saying, here is the key, learn it, and the rest of the message will reveal itself. It's the same logic humans used when we crafted the Arecibo message and the Voyager Golden Record. You don't start with language. You start with shared reality, numbers, ratios, constants. You start with the architecture of the universe. But here's where things get even more staggering. Beneath the primer lies a second layer, a denser, far more complex data stream that we still can't decode. SETI researchers describe it as something analogous to a compressed holographic file, the kind of high-density encoding you'd use if you were trying to send an enormous amount of information across astronomical distances without wasting bandwidth. To put it bluntly, if the primer is the alphabet, the second layer is the encyclopedia. Now, consider what that implies. The object isn't just signaling, it's teaching. It's preparing the recipient, us, to understand a larger message. But decoding that deeper layer isn't just a technical problem, it's a philosophical one. Because it suggests intention, patience, and perhaps most unsettling of all, expectation. Whoever engineered this system assumed the reader would be capable of mathematics, logic, physics. They assumed the decoder would be intelligent, technological, and curious. They assumed someone like us. For the first time in history, humanity wasn't looking at raw data from the cosmos. We were looking at something built by a mind. And as breathtaking as that realization was, the universe wasn't finished surprising us. Because while scientists were decoding the primer, telescopes around the world were detecting something else, moving with 3i Atlas in the darkness, something that made the mystery exponentially deeper. The moment confirmation of the formation reached major space agencies, the tone of global discussion shifted from scientific fascination to strategic urgency. Suddenly, this wasn't just an astronomical event, it was a geopolitical earthquake. Within hours, NASA, ESA, CNSA, Roscosmos, and JAXA initiated emergency task forces, diverting resources, personnel, and supercomputing power to a single priority: understanding what was approaching, and deciding how humanity should respond. For the first time since the dawn of the space age, every major agency on Earth was staring at the same object with the same fear. NASA was the first to publicly acknowledge unusual behavior from 3I Atlas, but behind closed doors, the language was far more direct. Internal memos referenced coordinated multi-body motion, potential intelligence indicators, and the need for controlled engagement protocols. Engineers at the Jet Propulsion Laboratory worked through the night, sketching early concepts for a rapid intercept probe, repurposed from existing hardware, anything that could be launched within months, not years. The idea wasn't to land or make contact, but to get close, to see these objects up close before they reached Earth's neighborhood. Across the Atlantic, ESA reacted even more aggressively. On an emergency teleconference, agency leadership proposed something unprecedented. A crash program mission, built in under a year, cannibalizing components from unfinished satellites, old mission hardware, and anything that could be modified for high-speed pursuit. European engineers compared it to the Apollo era, except this time, instead of racing another nation, they were racing the unknown. China took things a step further. While Western agencies debated collaboration and safety protocols, CNSA quietly began drafting plans for a swarm mission, multiple small probes, launched in quick succession, designed to surround 3I ATLAS and its escorts from different angles. Their calculations showed that the window for intercept would shrink dramatically as the object approached, meaning the first nation to launch would likely be the only one to gather meaningful data before the flyby. Russia, lacking the rapid launch infrastructure of the U.S. or China, pivoted in another direction. They began constructing the largest virtual telescope array ever assembled on Earth, linking observatories across their vast territory into a single interferometric instrument. Their goal wasn't to intercept, it was to listen, to decode, to uncover whatever hidden layers might be embedded in the radio emissions that SETI had already identified as structured communication. And through all of this, a quiet tension grew between nations. On surface-level press releases, every agency emphasized unity and scientific cooperation. But in private, governments were asking very different questions. Who gets access to the data first? Who controls first contact? Who benefits if the incoming objects possess technology that could shift the global balance of power? Because make no mistake, alien technology wouldn't just change science. It would change everything: defense, energy, communication, economics, and even the concept of national sovereignty. A single breakthrough propulsion, materials, energy generation could launch one country 1,000 years ahead of the rest. That looming possibility ignited the most intense scientific scramble in history. Overnight, the world entered what many are already calling the second space race, but this time there is no moon to land on, no rival nation to beat. The finish line is an object hurtling toward us, an object broadcasting signals we barely understand, surrounded by companions we cannot classify. And as engineers debated trajectories and diplomats argued over protocols, a more profound question gnawed at everyone watching the sky. If we scramble to reach 3I Atlas first, what if the objects already know we're trying? Because while Earth's response was fractured and frantic, 3I Atlas and its 6 companions continued on their course, steady, silent, and undeniably purposeful. And with every hour that passed, one date drew closer: December 28, 2025. A date that would change everything. In the days following the maneuver, the world entered a strange kind of collective suspension, half anticipation, half dread. News networks ran 24-hour coverage. Stock markets lurched unpredictably as investors tried to price a future in which alien technology might land within observational range. Religious leaders invoked ancient prophecies. Scientists gave measured interviews they barely believed themselves. And ordinary people stepped outside at night and stared upward, searching for a faint point of light that wasn't there yet, but soon would be. Because one number defined everything now: 43 days. That's all that separated humanity from the closest approach of 3I Atlas, December 28, 2025. You could feel it everywhere. In airports, strangers whispered about the object. Governments quietly reviewed contingency plans that had never been meant to see the light of day. Social media filled with theories, fears, prayers, jokes, and that eerie kind of humor humans use when they don't know how to process something enormous. For some, the object became a symbol of hope, an answer to the loneliness of the cosmos. For others, it became a threat, a countdown to a moment no one could predict. And for millions, it simply became a mirror reflecting back their deepest anxieties. As the days passed, telescopes tracked the gradual increase in brightness. The once invisible visitor was slowly becoming a moving star. By early December, astrophotographers began capturing faint streaks through long exposures, proof that the object was no longer a theoretical concept but a growing presence in our sky. Soon, binoculars would reveal it. Eventually, perhaps even the naked eye. Every night, the same ritual unfolded across the globe. People stepping outside, heads tilted upward, wondering what was rushing toward them through the void. It was as if humanity had collectively rediscovered the sky, not with wonder, but with unease. And in labs and agencies around the world, the real work intensified. NASA transmitted mathematical responses, prime numbers, atomic diagrams, elemental maps across multiple bands, trying to acknowledge the primer sent by 3I ATLAS. Europe transmitted its own signals. China sent high-powered laser pulses encoded with structured data. Humanity wasn't silent. It was shouting. But the cosmos did not shout back. 3I. Atlas maintained its steady beacon, repeating the same cycle, never acknowledging or altering its transmission. This silence became its own mystery. Was the object indifferent, focused on some mission that had nothing to do with us? Or was the primer itself the only message we were meant to receive, a declaration rather than a conversation? That ambiguity wound itself into every discussion, every debate, every late-night emergency meeting. Some experts argued that the silence meant the object wasn't here for us at all. Others feared it meant the opposite, that it had already assessed us and found nothing worth dialogue. A few warned that the primer might not be a greeting, but an announcement, a demonstration of capability, a display of understanding, a signal that our world had been noticed. And still, the countdown continued. Meanwhile, a quieter shift was happening among the public. The awareness that humanity was no longer alone forged a fragile, surreal unity. People who had never cared about astronomy suddenly followed orbital charts like sports statistics. Political arguments softened. Borders felt smaller. Even the loudest skeptics, the ones who dismissed the first reports, denied the evidence, or clung to comfortable explanations, began to waver as the object brightened night after night. Something ancient and instinctive stirred in us, the realization that our species was now facing something far larger than itself. On December nights, families gathered outside with hot chocolate, telescopes, or nothing but their eyes. They pointed toward that drifting pinprick of light, the one moving a little too fast, shining a little too steadily, and felt the weight of history press against their chest. Children asked their parents if the visitors would be friendly. Parents gave answers they did not fully believe. And across every culture, every language, one question whispered beneath all the noise. What happens when it arrives? For now, no one knows. Scientists can model trajectories, governments can plan missions, and philosophers can speculate. But the truth is simple. For the first time in human history, something is coming toward us from the stars, and its intentions remain unreadable. The countdown continues. The sky grows brighter, and humanity waits hopeful, terrified, united in uncertainty. Whatever happens on December 28, 2025, one thing is already clear. We are no longer alone.